Testing, testing. There we go. Can you hear me now? If you're talking, I'm unable to hear you. So I don't know why my setting seems to change automatically a lot of times. You may be on push to talk, by the way. Oftentimes when people first join, it has them on push to talk. Testing, 1, 2. Yeah. So everything is working fine on my end, it seems. I can't hear you, Juan. Check and make sure you're not on push to talk. That could be it. And also, let me, I can switch my camera so I can turn my camera on the Discord as well. And actually, that might make it more complicated. I see that you're talking, but I can't hear you. Are you able to hear me? Maybe you could put in chat if you can hear me. So if it's not push to talk, if you go to, are you new to Discord or are you familiar with Discord? A thumbs up or a thumbs down, right? If it's not that, what's going on, Lisa? Awesome. Glad you can hear me. We're trying to get Juan's audio here. I think, so why don't let me show you settings really fast. And maybe that'll help. And actually, I can't actually share my settings to him inside the Discord because I have to share with Discord. But if you click the little user settings one, it says user settings at the bottom. It's a gear. And at the top, it says input device, output device. You can go ahead and change your input device to something that works better. Another thing you can do as well, when you click the little gear at the bottom, user settings, go to video and voice and video and say, let's check. And when you click let's check, it'll let you check your mic. What I'll actually do is I'll take a screenshot and put it there. So I'll put awesome, and we can use this chat here. So that's the image right there. If you see that image in the chat, click check. There you go. I can hear you now.
Oh, you hear me now?
Awesome. Yes, I can hear you.
Okay, great.
Awesome. Glad we got that worked out. Yeah. So I don't know what it is, man. Even me, I have my settings the same way every time. When I restarted my computer before I came back home, and still it just automatically changes settings. I have to fix them out too. So it's something to do with, I don't know, it's just computers, man. Awesome. How's your day been going?
Okay. Everything's so fine. Everything's okay.
Fine as well. Doing some homework and studying, preparing for an exam this week. So awesome. So we can jump right into it.
Oh.
So good time. And I'll stay up front. I'm skeptical, but I'm willing to hear what you have to say and challenge what you have to say. And perhaps we could all hear a Nobel Prize winner in the making right now. So what I'm going to do, I'm going to share. Go ahead.
No, I'm mainly going to present the titles. It's quite revolutionary in many senses. So I think I hope you find it interesting and
you have a
maybe
presentation?
research it yourself. And what?
You say you have a presentation to present?
Yes.
Okay, so let me certainly. So let me take this down and I'll put your presentation up. So all you have to do is click share in Discord and it will allow you to share your screen. And once it's sharing, I'll put it up so everybody can see. There we go. Watch stream. And so
So
right
now
now,
you
I
see my
think you're
screen.
sharing. Yes, I can see your screen. Awesome. Perfect.
Awesome.
So why don't I give me a
Perfect.
moment? Let me adjust the size of it a bit so it could look a bit better.
Okay.
Why don't I do this crop? Awesome. So that's perfect. So now everybody
Okay.
can see your screen share. Okay, let's go.
Okay. Well, first of all, thank you for having me.
Okay.
Uh, let me first say how I got to know this Tychos system. Like many others, I started trying to debunk flat Earth,
Okay.
and I got into Tychosium because one of the things I heard the flat earthers or others was this quote of George Ellis. Uh,
What was that? What was that again? Who did your name? Can't hear you if you're talking.
uh,
I can hear you
and
now. I can hear you now. What name did you say? You got into who? I think your audio might be going in and out.
let me know.
Uh, I can hear you now.
Do you hear me now?
Yes, I can hear you now.
Okay.
Okay, keep on going.
So okay. So I get to the Tychos because I was trying to debunk flat Earth, and I came across this quote of George Ellis, in which he says that I can construct for you a spherical symmetrical universe with Earth at its center, and you cannot disprove it based on observation.
Okay.
And that sounded crazy to me because I thought, how could it be possible that we cannot know if the Earth is at the center or not? Uh, so I started digging or researching, and within a week of searching about this particular issue, I found the Tychos, and this was developed recently by Simon Schack and Patrick Holmquist. Simon Schack is like the mastermind behind this system, which is like an updated Tychonic system. And I think it's worth mentioning also Patrick because Patrick is a programmer and he developed a 3D model viewer,
Okay.
and I think it's equally important because uh, just after the 3D model viewer was constructed, the geometric configuration of the system allowed for a lot of new discoveries and explanations to certain astronomical observations. So the real mastermind behind the system is Simon Schack, but Patrick, being the programmer who put together the 3D model viewer, he is as equally important. And uh, I would like to apologize to them in advance because I don't claim to be an expert in their system, but I really encourage you or anyone to further research it, and maybe give your opinion.
Thank
So
you for sharing that.
this is eh?
Thank you for sharing that.
What?
I was
Okay,
saying thank
okay.
you for sharing.
This yes, yes. Okay, you're welcome. this is the basic configuration of the system. It has many things that will sound a bit crazy to many people, but this is what standard physics call the inner planets. You got Venus, Mercury, Mars, the Earth, and one of the main crazy things that this model proposes is that here the only planet we see here is Earth, because it's a binary system. The Sun and Mars are the stars of this binary system. Venus and Mercury are the moons of the Sun, as Mars has Phobos and Deimos as its moons. How is an updated version of the Tychonic model is because this Simon Schack discovered or developed or proposed that the Earth has this orbit, you can see in light blue, which takes like 25,000 years to go around. The Earth moves in this orbit at 1 mile per hour, really slow. And this configuration ended up explaining a lot of astronomical observation. We will get more in deep. We will get deeper as we go forward.
Okay.
But let me show you real quick the model. It's free online. It also has a free book. So this is the system. It's 3D. It had also, for example, the stars. You can turn it on. I don't know
Now, right
if you
now,
can
I
see
can
it right,
still
but
only see that first page. Like, I can't see. All I can see is the thing that says Tychonium, Simon Schack, Patrick Holmquist with the
okay.
image on the left. So,
Hey, it doesn't matter. We keep at the end of the presentation. I can show the 3D model.
okay.
But
And what did you
the
say,
main
by the way?
thing here is that
And what did you say as far as the orbits, by the way? You said what are moons of the sun?
Venus and Mercury are the moons of the Sun, just like Phobos and Deimos are the moons of Mars. So Mars and the Sun are the two stars of our binary system for the Tychos, and the Moon, and Earth is at the center of this model. So one good thing about this model is that it's not geocentric and it's not heliocentric. So I think maybe someone find it quite refreshing to hear that this is a new model that is not geocentric and it's not an heliocentric model. So maybe I can try to convince someone to take it as a good model or not. This is a list of supposed puzzles that the Tychos claim to solve. We get into some of them as I present. Maybe, and this is I will get into a little bit in that claim of the gravity theory, in which many years ago I questioned myself: could the universe be an electrical phenomenon? And because in the heliocentric model, the configuration of the system is supposedly ruled by gravity. And I have this quote by Neil deGrasse Tyson, in which he said, we can describe gravity, say what it does to other things, we can measure it, predict with it, but when you ask what it is, I don't know. So I'm not against the theory of gravity. I think it's a good model. It's great. I'm fine with it. But the issue is that we don't really know what gravity is. At least that's what Neil deGrasse said, or other physicists also mentioned. So, could the universe be an electrical phenomenon? And this is one of the guys I talked in the other video. It's called Robert Distinti. He proposed a new electromagnetism model and ethereal mechanics. It's basic. He has for the electromagnetism, he has these three models for the Coulomb law, this formula for new magnetism, and a new induction. And he has an ethereal mechanics universe, to say it in a way, in which bodies consume ether, and he creates a whole construct, mathematical construct, in which he can explain several things. I'm not saying he's absolutely correct in with his model, but it just give the option or an alternative idea of explaining gravity or other phenomena using entirely an electromagnetic framework. That's the idea. For example, he has a model of matter in which you have, for example, this is the electron, the proton, and the neutron, and he proposed precursors to those subatomic particles he called pretons, inertialess particles, and he has a model of matter with these pretons, and he uses his induction model, which is the third equation here, and he, for example, predicts the mass of the electron, which I think is pretty cool, given that he does this using only electromagnetism.
You say he predicted the
Another,
mass of the electron with he used what exactly?
He used his induction model using the charges. I mean, I think we can go. I really encourage you to get into what this guy proposed to really analyze and see what's what. But
Why don't we
he
into some details with it? Because this seems to tie directly into the image you had, the which you had shared in the chat. So perhaps you could explain how this model addresses these things, and I could see if I can challenge what you're saying with what we understand. Like for instance, you said in your post that gravity and its expressions are pretty fancy, but have a fundamental problem.
yes.
It uses an arbitrary constant g. Arbitrary constants are
Yes,
placeholders for missing
I
pieces.
will get
But let
the.
me make sure I read. Want to make
I,
sure everybody understand where you're coming from here. Arbitrary constants are placeholders
yes,
for missing pieces of the puzzle. If you know how it works, then nothing should be arbitrary, period. So what do you get that g as an arbitrary constant?
this is what Robert Distinti is talking, and constants of relations. I can have it in here. Arbitrary constants of relation, a constant of arbitrary unit that may not actually make sense and cannot be directly measured, used to relate measured values to one another. So we have the Cavendish experiment, but this is not a law, it's a model. This is an empirical model that works wonderful, it's great, but the units of the G constant not necessarily make sense. The units are just there to balance the equation between force and the rest of the equation. And for example, Robert Distinti, with his model of mass, he reaches the value of the gravitational constant completely using electromagnetics. So
Right.
I'm not an expert, but
let me ask you this.
yes.
Um, um, how then does the constant remain no matter what size of objects are attracted? How can it be arbitrary when it's consistent no matter what the size or distance of all the objects?
Because it is a constant, but the units that don't necessarily make sense. The units of the gravitational constant are just there to balance the equation. I mean, it's a real number, it's accurate, it helps describe phenomena and predict awesome, but
When you say it doesn't
they
make
don't know what
sense,
gravity is.
when you say it doesn't make sense, like what's the criteria where you're saying it doesn't make sense?
Well, this is what Robert Distinti is proposing. I really encourage you to get into it and
But this is the
maybe
thing. This is
challenge him.
the thing. This is the thing. Just because somebody said it doesn't make sense, that doesn't really mean anything. So, like, did this guy, does he have any inventions that are more accurate or work better than what we have? Has he built any buildings with his model? Like, what does he have to
Yes,
demonstrate that what he's
yes.
saying?
Distinctly received an MS in electrical computing engineering from University, over 25 years experience in diverse engineering disciplines, including microwave, hologram, pneumatic,
I'm
physics,
I'm not
instrumentation, and embedded
saying that
system.
he used university instruction
His
to build something. What I'm saying is,
no, here his personal research includes development of improved electromagnetic physics models that were used by Texas A&M Nuclear Physics Department for explosive flux compression generators.
we're
I
gonna need to be
mean,
more
his
specific.
theory was
Maybe I need to
used.
be more specific. Maybe I need to be more specific. We're talking about gravity.
Yes,
Or you're saying that that the constant doesn't make sense. Does he have
the units of the content.
the the units don't make sense? In other words,
Yes.
him saying the units doesn't make sense doesn't mean anything. That just doesn't mean anything.
Okay,
So
I take your point.
huh? Say again?
I take your point. I don't have a
Yeah.
problem with you with the point you're making. I'm just saying that he arrived at the same expression of the G constant using purely electromagnetics, not fabric of
Well, let's see that
space-time,
then.
not
Let's
not
see
anything
that.
else.
Perhaps
So
that we need to see. Let's see the math behind that, and maybe that'll illuminate us about something. So instead of sharing
well,
like
I'm not
like
an expert in math, but for example, he takes his model for neural magnetism and he derivates and arrives to the expression of time dilation.
before
And
we
in
move to
his
something
model,
else, wait,
he
wait. Before we move to time, did I hear you correctly when you said he used his electromagnetic theory to arrive at the same G constant? Did I hear you correctly?
this is how he arrived at this is how he arrived at the gravitational constant using pure electromagnetics.
Okay, so let's see that. Let's see that. Let's see that. Before we move to time or anything else, why don't you stop sharing this thing here and let's see the what you're talking about with the derivation to get the G constant.
I
And I guess to him it makes sense how he did it. So let's see that.
I don't have it here. I don't have here his paper in which he derives this value, but I'm not trying to say that gravity is wrong. I'm just saying that a guy took an electromagnetic framework and make predictions just as good as the gravity theory. That's all I'm
Like
saying.
this. Why don't we do
So
this? Why don't we do this? Why don't we just limit the discussion to what you can show? Because you're saying a lot of things, but so far all we've seen is just this image and this person is saying something. So the first thing I addressed, you know, gravity constant. You said the guy said it doesn't make sense, which is irrelevant. It doesn't. Maybe it doesn't make sense to him. It doesn't matter. So that doesn't mean anything. But then you said that he derived it with electricity, electromagnetism, but you don't have that. So that means that's nothing. So just saying he derived it, but we can't see the math to see maybe he made a mistake, maybe he's lying, maybe he just we don't know because we can't
it
see
could
it.
be lying.
So why don't we go to something
Yes.
that you can show, and then we could look at it now. So that was the first thing. So there's nothing on that. So okay, so let's go to the second sentence. The only person who addressed the issue got the only person who addressed this issue and got away of orbiting constant is Ardestini because he solved it with ether mechanics and electromagnetism. So known concepts of gravity, relativity, quantum physics, and other fancy stuff goes out the window. Okay, let's look at that. Let's look at this Ardestini thing. Do you have that to show that this ether mechanics makes gravity and everything go out the window?
I don't have it in this presentation.
What I'm saying is, I understand it may not be
I'm
on the screen now, but I'm saying, do you have it so you can stop sharing this and can share that?
no, I don't have it here.
Okay, so we're going to skip that one then. So let's go to the next one. The ether problem. Einstein
Okay.
clearly stated that if ether was detected, then his theory was wrong. Well, bad news for Albert. Michelson, Morley, and Dayton Miller experiments didn't come out with a null result. They in fact detected ether. So let's start there. Let's see where you found that they did detect ether. Like where is that? Like did you find it in their paper? Did you like how did you gather that they did find ether?
Uh, I can go there. We can just keep presenting the tychos and see what you think. Can you hear me?
You're saying present the typos, but what I'm understanding is the presentation of the typos is what you have on the screen right now, right?
Yes.
So we've already seen that, and you talked about that, and I gave you the time to talk about that. Now I want to go into details behind how this stuff works.
Okay, let's
So
go
so
into
so
Ether.
yeah.
Now, fast forward in time to the most fascinating French paper published in 2007 by Pierre Fauxer under the title
So let's
in
share
French.
that.
I
So
don't know.
in other words, stop sharing what you're
Fauxer.
sharing now and share that so we can see what you're talking about.
This is about Ether, the detection of Ether.
In other words, are you looking at a paper on your screen? Like you have a scientific paper that you're looking at
No,
right
I'm
now?
not looking in a paper on my screen. I just put it in the presentation.
Yeah. Oh, so
You
let's
can
scroll to that
you can
page then.
search for this paper online
Well, let's scroll to that then. In other words, you say the paper is in your presentation. Scroll to that page so we can see it.
can you see it? Can you
In
see
other words,
my
right
screen which
now,
said was Ether detected?
no. All we see is the first page that says Tychosism by Simon Schack and Patrick Holmquist. That's the only thing we'll be able to see the whole time.
Sorry.
Uh-huh.
Entire screen.
Right. So we have something else showing here. All right. So right now I see the disc. Okay. So now what's up? All right. So
I don't
let's
know why
see
it's
where
not
they discovered
working.
ether.
Can you see the screen and me
Yes,
going
I
through
see it
the?
scrolling now. Yes.
Okay, this is the system in which Venus and Mercury are the moons of the Sun, just like Phobos and Deimos are the moons of Mars. This
Mhm.
is Earth. This is the orbit of Earth, which he calls the PVP orbit. The Earth takes
Well,
25,000
let's stay
years to
focused
go
now.
around.
I'm happy to look at that, but let's stay focused on how Michelson morally. How did you
On
gather
the
that they
ether,
did find ether?
was ether detected? I'm covering this Fauxer, which is a radar engineer and signal processing specialist who worked closely with eminent physicist and economist Maurice Allais. When Maurice Allais performed a statistical examination of Dayton Miller's data, he found that the sheer coherence and statistical consistency of Miller's vast body of observation was such that it could not be dismissed as spurious or systematically flawed, as Miller's opponents had argued, eventually throwing his entire body of work into disrepute. In short, Miller's data had shown that there was a regular diurnal dissymmetry between civil time and sidereal time, and that this dissymmetry also manifested over a 6-month periodic sinusoidal curve peaking at the equinoxes. Dayton Miller performed over 326,000 turns of interferometer with 16 readings each one. They show what appeared to be a small amount of drift, about 9 kilometers per second, of the 1/3 of the velocity of Earth around the Sun. So it's not like it's not like ether wasn't detected. It's just it didn't comply with what the heliocentric model was expected. And the
Where
titles,
does this
by
demonstrate that ether was
coincidence
detected
or
though?
because it what
Where or how does this demonstrate that ether was detected though?
it demonstrates ether was detected because a drift was detected, in fact, and the sheer coherence and statistical consistency of Miller's vast body observation was such that it could not be dismissed as spurious or systematically flawed.
And this drift, what does this drift mean? Like, what is this drift and what is it in relation to?
The drift means that ether is changing the speed of light. So light is being affected by ether. they said it was a null result because it didn't comply with the heliocentric model, but the Tycho's model fit perfectly into what was found.
Let's see where they didn't do it because it didn't fit the model. Like, where are you getting
For
that from?
example, the result, for example, because the Earth is moving at 1.5 kilometers per hour in its orbit, you get an apparent velocity variation of the moon of 0.8 kilometers per hour. What was found in Dayton Miller and Michelson Morley and others is the result of most of the various Michelson type experiments performed over the years, as shown by Forster, detected a speed of light variation of around this number, where other rigorous experiments have yielded a marginally smaller value. Forster concluded that the experiments pretty much agreed with each other. This contradicts the widely believed notion that the interferometer experiments conducted by different scientists have mostly yielded inconsistent or null results or have been afflicted with systematic error associated with temperature variations or whatnot. So this variation ended up being 0.8 kilometers per hour, which is exactly what the Tychos predict. So let's call it, let's say it's wrong. Let's call it a coincidence, not a proof of nothing. And I'm not claiming this is proof of anything as for now.
Before we
And
move
from
on
the
though,
Tychos,
before we move on though,
yes.
I would still like an answer to that question though. Like, where are you getting that Michelson measured this, but they just didn't report it as such because it didn't fit a model? Like, where are you getting that from?
This was detected. This is fact, historical fact. It was detected a drift of 9 kilometers per hour per second. They just
Be more
couldn't
specific. In other words,
make
can
it
you
work
show
in the
me in
heliocentric.
Can you show me in Michelson Morley's work that they found the results you're saying, but they didn't report it just because it didn't fit the model? Because that's what you said. I'm still
Well,
wanting to get.
this is Dayton Miller. This is Wikipedia. I mean, you
Okay.
can go and look it for yourself.
Well, this is my point. You let me. You said that uh, uh, the ether problem. Einstein clearly stated that the ether was detected. Well, bad news. Albert, Michelson, Morley, and Dayton Miller experiments didn't come out with a null result. They in fact detected ether. So I'm wanting you to show where Michelson and Morley did in fact detect ether, and the problem was that the result didn't conform to their heliocentric model, so that's why they hit it or something. Where are you getting that Michelson Morley detected ether?
I'm getting it's a historical fact that Michelson Morley detected a small drift that it didn't comply with the heliocentric model, but a drift was detected.
Well, I'm asking you to show
That
me,
is
because
fact.
in
I
other words,
mean,
what I'm saying, this is, I hear you saying it's a historical fact, but the only thing I'm hearing you refer to it, the only basis I'm hearing it that's an historical fact is that you're saying it's an historical fact. Like, when I looked at their paper, I didn't see anywhere where they said we did detecting ether. So in other words, specifically with Michelson Morley, what historical document or what have you are you referring to, or do you have any of that, or is it just someone said that it's historical? Like, what actual historical thing can you refer to show us that Michelson and Morley detected ether?
I mean, I don't have it in here, but it's an historical fact, and Dayton Miller detected a small drift and others as well. So that's
Okay.
my point.
So
That's about it.
this is my position on this. Uh, you saying it's a historical fact, but not able to back it up with
Yes.
historical data means I dismiss it as a historical fact.
I back
Um,
it up with historical data with quoting Wikipedia, Dayton Miller, and that's about
well,
it. I mean, if
yeah,
you don't like it,
Wikipedia
I
is
mean,
not a good source. Yeah.
I can do nothing about it.
Okay, so we can move past that. Yeah, because I'm not gonna. Yeah, science doesn't work because
I can
it
do
says so
nothing.
on
I can do
Wikipedia.
nothing
Yeah,
about it. I mean, it's
I got
this
you.
is Wikipedia. Dayton Miller detected a drift of 9 kilometers per second.
Yeah, yeah.
That's
All right.
that's
So,
about all I have to do to say about it.
okay, sounds good. Yeah, yeah. So, yeah, yeah. So, the answer. In other words, the my position is not that all of science, like you said, gravity, relativity, quantum physics, all of that doesn't go out the door just because Wikipedia says something about a guy. That's not the way it works.
Well, Einstein said that if ether was detected, his theory of relativity was of no use. So, according to Dayton Miller and others who did similar experiment, they detected a small drift. So, ether is affecting light. Ether is real.
Right.
So,
Well, I guess people could decide if uh, because you're saying a Wikipedia article says it, everything else is out the door. People could decide, but like I said, no.
it's
Like
out
I
the
said,
door because in fact it was in fact detected. So
right.
that's
In other
my
words,
point.
you saying it was in
I
fact
mean, we can
detected
argue
doesn't
about
mean
it
it was
all
in
day,
fact
but
detected. Like I said, when I read the Michelson Morley paper, and admittedly I read it quickly, but nowhere in there do I remember them saying that they detected ether. So that's the historical document that presents the result of the experiment, and is not matching what you're saying. Now, this Dayton Miller guy, uh, uh, you know, I haven't looked at. Maybe we should pull that up and see what that article is. Let's take and pull that up and take a look at it real fast. That seems like a good place to go. If you're talking about this Wikipedia article, then that's your evidence for it. So
okay,
give me a moment. Let me pull it up.
okay.
All right. Let me see here. Or if you want, you can pull it up. I mean, you have your screen right there. Let's pull up the Dayton Miller article and see what it's talking about. I'll put the
No,
link
no,
in.
you search it. You search it. I will try to find the Michelson Morley.
Yeah, again.
You search it for the Dayton Miller. I try to find the Michelson Morley.
Okay. I mean, I want us to be on the same page. So if you want to find the Lucas and Morty, we could focus on that. If you Maybe we should both just focus on the Dayton Miller thing, since we were just talking about that, and we can go to Mickus and Morley after this. So we could. I mean, I don't necessarily want us to be looking at two different things. Uh, Give
Okay,
me one
okay,
moment
okay.
here.
Let me
So
go
let
to the
me. Matter
book.
of fact, hold up. Let me
This is
share
the
it with
book of
my
the Tychos.
Discord. Before we go to something else, I find this is common with like whether it's flat earthers or whatever, uh been like it's changing subjects so quickly that we can't really get into anything. So let's stick to the Dayton thing. We were talking about Dayton, and at least see what this was talking about. So so are you able to see the article there, the Dayton Miller article? Are you able to see it in the screen share? You might have to stop sharing your screen. So let me try to find what was the quote, by the way.
9 kilometers per second.
Hold on a second. Like, would you read that sentence real fast? I'll do a search for. Oh, here it is, right here. Dayton Miller performed 3,600 terms of the interferometer with 16 readings each. They showed what appeared to be a small amount of drift. With white light and 32-meter arms, he could see nearly always the same result. Amplitude suggests a drag of ether, but the analysis of phase suggests that the solar system goes towards constellation Drago. At even also presented to Miller. The drift, however, the effect Miller saw was tiny, much smaller than would be expected for a stationary ether. In order for these results to be consistent with ether, it had to be assumed that ether was dragged along with Earth to a much greater extent than ether theories predicted. So what the article you reference is contradicting what you're saying. These results were presented by Miller as a positive in existence of ether drift. However, the effect Miller saw was tiny, much smaller than would be expected for a stationary ether. In order for these results to be consistent with an ether, it had to be assumed that the ether was dragged along with the Earth to a much greater extent than ether theories predicted. Values that had to be eliminated due to other physical phenomena like stellar aberration, which puts upper limits on the amount of drag. Based on error analysis, Miller's critics argued that he overestimated the precision of his results. So based on error analysis, Miller's critics argued that he overestimated the precision of his results and that his measurements were accurately perfectly consistent with the fringe difference of zero, the null result that every other experiment recorded. However, Miller continued to defend his results. Einstein was interested in the ether drift, and acknowledge that a positive result for the existence of ether would invalidate the theory of special relativity, as you were saying, but commented that altitudinal influences and temperatures may have provided sources of error in the findings. Miller commented, the trouble with Professor Einstein, he knows nothing about my results. He ought to give me credit for knowing that temperature differences would affect the results. He wrote me in November suggesting this. I am not so simple as to make no allowances for temperature. During the 1920s, a number of experiments.
Yeah,
Well,
I
go
get
ahead.
the official explanation of how they try to reconcile the results, but the fact that in million terms of interferometer ether drift was detected and with a consistent value, you just gotta make your eyebrow raise your eyebrow. Uh,
Well, I mean, this is the
and
thing, and
other
I'll
smart
stop sharing
people
my
like
screen.
Forster
Go
and
ahead.
Maurice Allais, a prominent physicist, said that it could not be dismissed as a statistical error. So that is my point.
See, but or this is the thing. You're saying it can't be dismissed, but the very article that you shared as evidence said it can be dismissed. Now, uh, uh, so yeah. So I
Yes, the
mean,
article of Wikipedia, of course, is going to say that it could be dismissed, but other smart people analyzed the results and said it could not be dismissed as a statistical error. So that's the point I'm making.
why don't
And
we look at it this way?
and it's
Uh,
and it's
uh,
and it's quite interesting that the Tycho's model exactly predicts that drift.
right. Well,
Even the apparent velocity variation.
right, well, I guess we could disagree on that. I mean, like I said, the reference that you picked yourself said that you're wrong about your conclusion. This Wikipedia article that you read. So, you know,
Yes, of course.
this,
Of course,
this,
in Wikipedia, are going to say that they try to reconcile the results saying that it's null, but the fact remains that the results were not null. I mean,
I see. All right. So why don't we go to the next point here? Uh, uh, Tycho's, I'm sorry. The
well,
Tychosium
for
by
example,
Simon.
another important. I don't know if you can see my screen.
Let me look. Let me see here. Yes, I can see it.
Okay, the Tychos. In the Tychos, you have to apply a reduction factor the distance of stars because, for example, for the transit of Venus in the Tychos, all the distances between celestial bodies is correct. It matches what the heliocentric model proposed. But for the stars in the Tychos, in the heliocentric model, the Earth travels 300 million kilometers in 6 months. But in the Tychos, the Earth goes around this small orbit at 1 mile per hour. So in 6 months, the Earth only moves like 7,000 kilometers.
Mhm.
So the parallax, you should, according to the Tychos, you should adjust the distance to the stars, reducing by 42,633 factor.
Why don't we look at this thing?
And this
Why
is
don't you go
where,
back to that model that you had, like the model with the planets and everything?
can you see here the model?
No, in the same thing. Like because this is like go back to the slides that you had, and you showed, and you wanted to
Okay.
talk about that anyway. Like you showed like the planets, like you're right there, right there.
This is
So using this
this model.
model, when for instance will
Yes.
Mars next be in conjunction? Like when will that be, and how do you predict that with this model?
This model matches astronomical observation for thousands of years back and forward.
Okay, so that's what I'm asking. I'm asking you
And
to
for example,
when for instance will Mars next be in conjunction using this model?
when,
Yeah.
repeat please,
In other words, when is the next time Mars will be in conjunction using this model?
in conjunction with what?
In conjunction with the Earth and the Sun. When is the next time will Mars be in conjunction? And how do you predict that with this model?
I'm sorry, I can't show.
Well,
Let me see
let me
if
ask you
I
this:
can.
predict anything. When What have you predicted with this model as far as the position of the planets and everything? And how do you do it with this model?
For example, this is a comparison between Stellarium and Tychus.
Mhm.
And you can see a guy called Professor Parks did a review of the Tychus, and he compared different dates between the Tychus and Stellarium, and they match really close. So,
All right. So what I'm hearing
that's
now
about it. I
is
mean,
after the fact. So you have one thing after the fact. So what I'm asking you to do is, when is the next prediction? Like when is the next, for instance, solar eclipse with this model, and how big will the shadow be? Where will the shadow be, and so on and so forth.
that eclipses in the Tychus work exactly like the heliocentric model. So
Okay,
it's no difference
so
in their work, exactly the same.
so hold up now. Let's go back to the image here, the image of the solar system. You know, the one with the, so that's not how it works in this model. So it's not the same, right? That's not how it works. So
Why
what I'm
not?
asking you to do is, well, because we understand that the Earth goes around the sun. We understand that all the planets go around the sun, not just Mercury and Venus. So that's not the same. So I find that's common for people to do that want to promote something different. When channels don't actually presenting some kind of evidence based upon their model, they say, "Oh, well, that's the same." It's not the same. You can see it right there, right? So if you
No, it's not the same. The Earth is at the center of the system. Of course, it's
that's
not
right,
the
but
same.
it's
But
different. So what I'm asking you
if
to
you
do
use the
is
model,
go ahead. I'm
why
sorry.
don't you share screen and open the model, the 3D model?
Okay. Well, so
Can you do
where's
that?
the 3D model? Yeah, yeah.
I give you the
And actually, hold up.
link
It's on your
here in the
screen right
chat.
there. It's on your screen right there. Just show your screen. It was right there. We can see it.
It's here.
Uh-huh.
Yes,
So when is the next
here's the
time,
model.
for instance, there will be a solar eclipse, and how do you predict it with that model?
Well, can you give me a date so I can go here? So when the heliocentric model is uh, predicting that an eclipse or something will happen?
I'm asking you to predict the next eclipse with your model. How do you do that
Well, I
with
will have
this?
to the conjunction of Mars with what? With the Sun?
No, we were
I
talking
can
about
give
the
you like
conjunction of Mars, and then
this.
then you seemed unsure about that. So then I went to solar eclipses. So how do you when will the next solar eclipse be,
Here you
and how
have
do
a
you?
conjunction. Here you have a conjunction of Mars and the Sun, for example, in 2042.
So I'm asking, like, when will the next solar eclipse be, and how do you predict that with this model?
Let me go to today's date.
Hmm.
We are at October 27. So you get the model to run. This is the next conjunction.
That's the next solar eclipse on that date.
Mars and the Sun conjunction. For the moon and in eclipse, let me go back
Well,
again
hold
to
on. Let
see a
me,
moon
since you already
eclipse,
have
for
it there, give me a
example.
moment. Let me write the date for the Mars conjunction while you have it there. What's the date for that?
2034, 2034,
Okay.
August 14.
Okay. So the next Mars conjunction is 2034, August 14. That's when Mars is between Earth and the Sun, right?
No, Mars is behind the Sun.
Okay. The yeah. I was thinking Mercury for briefly. That's when Earth. That's
Let
when
me
the
try,
Sun is between the
let
Earth and
me try,
Mars. Okay. So that's August 14, 2034.
let
And
me
when is the next solar eclipse with that model?
Solar eclipse. Solar eclipse is when the moon. Let me. Oh, that was too fast. We are at October 27. Let's go day by day. The next moon eclipse will be. This is solar eclipse.
Okay.
Our So in 2024, November the 1st, roughly.
2024, November the 1st. And where will that be?
South America, Brazil.
And what type of eclipse is it? Like, is it annular? Is it full solar eclipse?
I don't know exactly, but you have, let me check positions. Here you have all the values of right ascension and declination for all the celestial objects.
If we don't know
If
it,
you punch
we
the
don't know the.
numbers, you could get the.
We could crunch what numbers?
This is you. Go to the date, 2024, November the 1st. The time, the
Right.
model is set at UTC time, and you have the moon right ascension and declination, and sun right ascension and declination.
Give me a moment.
So you
I'll
can
be
check
there
that with
momentarily.
with stellarium mode. What?
So in other words, using that model, you're unable to
Yes.
say what type of solar eclipse will it be. Will it be full or annular or anything like that?
Yes. You can check that using these numbers.
So that's what I'm asking you to do. I'm asking you to give us that information.
What?
I'm asking you
The
to give
right
us that
ascension.
information.
I can check. I mean, you have to check exactly the time in which it's a total solar eclipse.
All right. So the
You will
first
have to
thing,
get the time exactly. You will have to know exactly what time it is that to happen and check using these numbers. It will match what NASA or the heliocentric or what the stellarium uh, is claiming
okay,
the
well,
date
let
to
me
be.
share my screen and look at this, and you can see what I'm about to show here. Give me a moment. I'll share my screen momentarily. Remember that I have to share in Discord. So here, solar eclipse. I went to timeanddate.com. I pulled up when the next eclipses are, and I'm not seeing any eclipse at all on the 1st of November. So that would be incorrect, unless I'm reading this incorrectly.
Well, maybe. I mean, I'm just doing roughly looking at the model running. I mean, I don't know if that's exactly, but I can see the moon in front of the sun. But if you give me the date of the.
But what I'm saying is, I mean, look at this. The next solar eclipse is in October, and there's nothing in November at all. So it's not close at all, right? There's a solar eclipse on October 2nd.
October.
Yeah, there's a solar eclipse October
October
2nd.
2nd already is past. October the 2nd, here's the eclipse.
Well, yeah. So there's one on
If you
October
punch
2nd.
if you punch the if you punch the date in the Tychosium, you will see that the moon will in fact produce a solar eclipse in the Tychosium.
What I'm trying to do is read when the eclipses were. We were talking about the November 1st prediction you just made. So what I'm saying
Yes,
is that
you said the next
that's right.
the 2nd of October already passed. So
Well,
it's in the
in other words,
past. You
this
say
is
the
what I'm
next.
doing. So bear with me for a moment. I'm going over the
Yes.
eclipses that were in 2024. Okay. So there was one in October on the
Yes.
2nd. There was one on April the 8th. There's no solar eclipse in November at all. So that model is wrong. It's not correct. Right. Not only could you
I'm
not
not
get the
saying that. I'm not saying that Tychus is claiming that in November is an eclipse. I just ran the model and roughly said that an eclipse will happen because I'm just looking at the model running. I don't know if you have to take into account the right ascension and declination of the celestial object to really know if the solar eclipse is going to happen.
Right. Well, I tell you what, man. When maybe you should actually. In other words, nothing here has passed the test so far, right? So let's go through what we did already. We talked about the gravitational constant. The reason
I I
why.
don't I I don't accept what you're saying because you give me the date, you give me the right ascension and declination of the moon and the sun of that solar eclipse, and I will give you the right ascension and declination of the moon and the sun in that precise date and time, and we can see if it matches the stellarium or not.
Well, that's backwards, Juan. In other words, you're telling me to give you
No,
the.
that's
You're
not.
telling me to. Well, hold up now. You're telling me give you the data so you can put it there, so then it can recreate what I'm telling you. That's not how this works. If your model is accurate, you tell me. You tell me this is the declination. You tell me this is the right ascension. You tell me this is where things are because your model works. So what it sounds like is what's going on is they made this little computer program and then they get the data from the globe. Because if I tell you the declination, the right ascension, and all of that stuff, I'm getting it from the globe model. So they take the stuff from the globe model, then you type it in, and then it retroactively shapes it to match. That's not a model. What a model is we don't
No,
give you any
no. This
information.
is
What a model is you tell us. You tell us the sun is here, the moon is here,
well.
everything
I
is
don't
here.
have the number, but if you give me the
Okay, so
time
that
to
means
do it, I can do it.
well, I just did. I said, when is the next solar eclipse? You could not do it. You got it wrong. So what I'm saying is the model you have is not
No,
working.
I didn't get it wrong. I
You
didn't
told me
get it
November
wrong. I
1st.
just
That's
ran
wrong.
the.
Okay. Okay. Let's just go to something. I mean, I don't know how much wrong it can be. I asked you when the next one is. You said November the 1st in South Brazil. That's wrong. There's no eclipse in November at all. That's wrong. It can't be any more wrong. It's just totally wrong.
Because I just run the model and just guess that that is when the moon and the sun conjunct, but not
Okay.
always the moon going around in front of the sun is a solar eclipse.
Okay. Well, if your model is such
That's
that that's
obvious.
how it works, you have to run it and guess. That's not a good model. Okay. So it's not working.
No,
So
running
so
and guess.
so
No. It's this is what I do. This is what I just did. But
okay. Well,
the
well,
model
well.
predicts precisely the solar eclipses and moon eclipses.
You could not
That's a
just
fact.
demonstrate
I
that, though.
mean,
You're saying it precisely predicts it, but you could not do that. That's the point. So, and we run into this a lot. So let's go back to the first thing, right? Going back to what we covered already. You said gravity theory says the constant is arbitrary. Your evidence for it being arbitrary is just the guy said it doesn't make sense. That's nothing. Uh, 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 we talked about
the units are
the,
arbitrary. That's a fact.
you can call them arbitrary all you want. That doesn't make it arbitrary. It doesn't make it not make sense. That's just whatever. That's just you saying something, or this guy saying something. That's irrelevant, right? The ether problem. We talked about the ether
No, that's
problem.
not irrelevant because other physicists say they don't know what gravity is, and gravity, the Cavendish experiment, is an engineering
But now
experiment.
you're
It's
talking
not a
about
science
something else. That's two
experiment.
different things. Saying the units don't make sense is totally different from the subject of us not knowing precisely what gravity is. Just like how we don't know exactly what a magnetic field is. Like we know there's magnetic fields. You see magnets attract things, but we can't like tell you this is what a magnetic field is composed of. That doesn't change the fact that there's magnetic fields. So saying that the units don't make sense. That's a totally different thing from us not knowing exactly what gravity is. Is there a gravitron particle? That's two different things. So again, so saying that the units don't make sense, that's irrelevant. So it doesn't make sense to you. You don't believe they make sense. That's irrelevant. So they don't make sense to you, or you don't think they make sense. We don't care, right? As far as us not knowing what gravity precisely is, okay. Well, we're still trying to figure that out. That still that doesn't mean that the units make sense
Well, I have
objectively,
something that
right?
I have more things that doesn't make sense if you want.
Again, that's irrelevant. You saying something doesn't make sense to you is irrelevant. Now, the way that you show it doesn't make sense is okay. We apply gravity here and it doesn't work. Right? It's just like how when we look at large things like clusters of galaxies, and we say, "Oh, gravity is not working there," and that's how we came up with dark matter. We realized, "Oh, there must be some other mass there." That's different. But you just saying it doesn't make sense. That's irrelevant. Anybody can say something doesn't make sense. That doesn't mean anything. Now going back down the list of the things we covered, we talked about ether. You presented a Wikipedia article to show that ether was detected, but your own article says it wasn't. That was an error, right? And then we went to
Yeah, they said it was an error, but other smart people analyzed it and said it couldn't be dismissed as an error.
okay.
So
So I
that's
mean,
about
but
it.
that's in the article. The article is saying this guy is saying it's true, but other people whose stuff actually works, right? In other words, we can use relativity to predict, for instance, the bending of light. I'm not seeing you presenting anything where ether predicts things that otherwise couldn't be done with ether. All I hear you doing is saying people said stuff. This guy said the units don't make sense, or I believe the units
Yeah,
don't make
but
sense. This person said, okay,
for example, gravity can predict the Mercury's anomalous subsidal precession.
oh, I can't
They
predict
say
what?
Einstein. This is Wikipedia. Einstein showed that general relativity agrees closely with the observed amount of Mercury's perihelion shift.
What? That's
This
what I
was
was
a
saying
powerful
earlier.
factor motivating the other.
Yes, exactly. That's what I was saying
What?
earlier. That's what I said. In other words, when you look at gravity, when you look at something real big, like a real big masses, people did the math and say, hold up, it's not adding up. And that's how we knew dark matter has to be there. Just like with the rotation of galaxies, we knew, okay, galaxies are going around at a velocity that's different than what we could predict with than what our gravity than what our equations would tell us. Oh, so there must be more mass than what we could see. The same thing goes in reverse. When we looked at Mercury's
Yes, but for example, stellar aberration
well, at least for the
found by
people who's
Bradley.
listening, before we go to something else, let me at least finish this point for at least the people who's listening. So going the other way, when we looked at the revolution of Mercury, we say, hold up, we can't account for it. There's a procession of the revolution that we can't account for until Einstein's relativity came along, and now we can. So that's correct. There's nothing contentious about that. Gravity has its limits. When you get into things that are very, very
No, we can't. No, we can't because they are falling short by 43 arc seconds per century. That's an anomalous precession of Mercury.
let's see that then.
So they
Let's
can't
see.
really
Hold up now.
account for the precession.
Hold up now. Let's see that. Let's see you share your whiteboard or your paper, and let's show that that calculation is wrong and that it's anomalous or something. I'm very interested in seeing that. So let's see you show that it doesn't add up with relativity or what have you.
Let me see.
Yeah,
This is
Real
another
Kindness, he
thing
says it doesn't. So
which
let's give him a
they
chance to show it.
they
Good seeing you, by the way. Real Kindness,
let
Splurge.
me
Oh, yeah, I apologize. I have to click watch stream. Let me click that. Let me take the chat down.
anomalous precession of. Here you have the quote. They, they can account for 43 arc seconds of rotation per century.
So, hold up
And
now. Bring it back up so I can read it. Bring it back up. Bring it back up. So it says in 1859, Urbain Le Verrier discovered that the orbital position of the planet Mercury was not quite what it should be. The ellipse of its orbit was rotating. Was hold up. It was a adjustment. There we go. Was rotating, precessing slightly faster than predicted by the traditional theory of Newtonian gravity. Even after all the effects of the other planets were accounted for, the effect is small. Well, that's what I'm saying. That's why we account for it with relativity. So, so if you're just repeating what I had already said, I was trying to say that. So what I was saying was that yes, when you look at Newton has its limits. Newtonian mechanics has its limits. When you get into things like a
Yes, it
large
has its
gravity,
limit, but the interesting thing is that in the Tychos, there's no need for anomalous precession. The geometric configuration of the system reached to the conclusion that there's no anomalous precession of Mercury's of Venus.
this is where we're at. This is where we're at with that.
Right.
I just gave you a chance to show the accuracy of this model by predicting something. I was asking about the Mars thing. Oh, by the way, I forgot to look at that, but it was some kind of issue with that. But you ended up getting it. I could look at that too. But okay. So then we went to the solar eclipse thing. That was wrong. So we know your model is wrong on
That
even
was wrong
basic
because
things.
I just
Right.
said a date
Right.
and I was wrong in the date, not the model is wrong. I
Right.
don't say the model is exactly predicting that date to be a solar eclipse. I don't know. I don't have the data. I will have to study the system
That
further
means
to tell
that
you
means at this
precisely
point is
when
wrong.
the solar
I'm
eclipse
sorry.
will happen.
I know you may not want to accept it, but that means at
No,
this point is wrong. So now, no, so now this thing
no,
here
no,
is
no. The
saying,
model is not
so
wrong.
this thing
The
here
model
is
is not
saying,
wrong because if you
so this,
get if you if you get the date in which the solar eclipse will happen, the Tychos will agree precisely in right
no
ascension
problem,
and declination for the sun and the moon.
no problem. Now this thing here is saying that we don't need to have a precession. So how do you account for the fact that we see a precession?
We see well, in other words, the perceived anomalies are nothing but the natural precession rates of Mercury and Venus, as related to the revolution around the sun and commensurate with our system. General precession. Heliocentric astronomers erroneously add 1 unit to Mercury's and Venus precessional motion because they believe the Earth revolves around the sun. When you take the Tychos and its geometric configuration, there's no anomalous precession. It's just what the geometric configuration gives. For example, another thing is Bradley, in his stellar
Oh,
aberration, he expected
oh,
the
no, no,
maximum annual elongation to happen over.
wait. So it sounds like you're saying we see the precession, but they're just saying our model accounts for it, so it's not anomalous.
Yes, it's not an anomaly. It's just what
That,
it is.
we don't care. We don't care
And
that they
he's
say our model accounts for it and not anomalous. That doesn't mean anything. That's just like
no, you
saying
don't care. Oh
exactly.
no, you don't care.
That's just like saying earlier when you said the units don't make sense. We don't care. So you're saying the units don't make sense. So you're saying your model accounts for it. You can say whatever you want. That's irrelevant. So um but that's that. So, but I was trying to go through. So I mean, for at this point, nothing. Hey, by the way, let me before I forget, let me look up the um the conjunction as well because maybe that was right. So the Mars conjunction, next Mars conjunction. So let's see if that was right. Uh, trying to find it before I share because I'm having to search around when it's the next Mars conjunction with Earth and the Sun. Well, okay. Somebody in the chat look and have the link to the next conjunction right now. You can help me out by adding it there. I'll be happy to add it. So let's see. Maybe they don't track that. Uh, yeah, I'm not able to find that one, but we was able to see the. But if you can find a official one before I can, please do so. But I'm not able to find pretty easily the next Mars Sun conjunction at the moment. So if want somebody in chat can find it, y'all can post it for us. But awesome. So we're discussing. So going back through where we were on your chat, we got through the first two paragraphs. The last thing we left off with was symbolic observation. Simply elegant way. Okay, so let's look at this part. The answer is yes. You said the tachonium. Looking at what you said again, the tachonium by Simon Schock is an updated tectonic model in which Earth is not at the center of the universe, but at the center of the solar system, traveling extremely slow through the universe at 1 mile an hour and rotating at 0.007 miles per minute, rotations per minute. This clever update ended up resolving many mysteries, explaining in a very simple and elegant way observational facts that make the heliocentric model geometrically impossible. Okay, so what observations make the heliocentric model geometrically impossible?
Are you seeing my screen right now?
Yes.
Well, negative parallax.
Okay.
For example, if this is the heliocentric configuration, in the heliocentric model, you will only expect to see positive parallax, because if this car is the Earth, this is the Sun, you see stars only on this window. So parallax between a closed star and the starry background should always give you a positive parallax. But if you go to historical data, you will find that half of the parallax measured is zero parallax. 25%, roughly 25% of the parallax is positive, and 25% of the parallax is negative. How they fix this error in the heliocentric model? Well, they say it's instrumental error, but in the Tychos, that's exactly what you will expect to find: 25% negative parallax, roughly 25% positive parallax, and 50% zero parallax.
I'm still not seeing what you mean by negative parallax, though.
Negative parallax will be like, let me see, I have something of parallax. This is parallax.
Mm-hmm.
If you're on a car and this is a light post and these are trees in the background, as you, for example, at this moment, this is the light post and this is a tree. Mm-hmm. When you move forward, you will see that the background trees or stars, as you move forward, will advance you. Here you see, for example, this star, you see it in here, behind the light post. When you move forward, this star is in front of the light post.
Yeah.
That is positive parallax. Negative parallax would be the opposite, which is geometrically impossible.
What is the opposite? I'm trying to understand what you mean. Like, what's the opposite? Oh, I'm sorry.
The opposite will be
that. The screen. One moment.
Here.
Sorry, Splurge. Thanks for letting me know. So let me reiterate what you said, so you don't have to repeat it. Hold up. But if you could keep that screen there. Who it is pointing out will be understand about parallax. So if you look at the red car at the bottom, right, and you see it at the bottom of the screen.
Yes.
So the object in the middle, it looks like is in front, the stars at the top. But then when the red car drives along, and now the red car is at the top of the screen, the object in the middle looks like is in front of the stars at the bottom. So we understand that that's parallax.
Let's take the star in the middle.
Okay.
Let's take the star in the middle.
Okay.
This, at point 0, this star is behind the light post.
Yes. Okay. Yeah.
When you advance, you will see that the star is in front of the in advance of the light post.
Okay, yeah, I see what you mean.
And negative parallax will be the opposite, which is optically and geometrically impossible.
I want you to
It will be
describe
like this.
what is the opposite. Okay.
The opposite will be that when you advance, these stars have moved here in front of the light post, which is not what happened optically.
In other words,
The heliocentric model, recognizes this is an. The explanation is that it is an instrumental error.
I'm still not catching what you mean though. If you can go back to the car illustration. The
Maybe this.
no. I mean, we can see
This
it
is
from
what
that
the
one. Just go back
Copernican
to the car thing,
astronomer.
because that's a pretty clear illustration of the car thing. Like go back to the car one.
Yes.
No, I mean go back to the car one. You know
This is
the one with the
ah
no. I mean the one that we had with the red car. Yeah, right there, right there.
yes.
So in other words, you're saying the car is at the bottom, but the car at the bottom, right? And you're saying the star,
Sí, sí,
like this. Well, hold on, let me just run by what I'm so I can understand what you're saying. So the car at the bottom is at the bottom, so the object is
yes.
in front of the star at the top. But you're saying that when the car moves up to the top, the star at the bottom, the star at the top has moved to the bottom. I mean, what are you saying is happening?
No, because this is for Mars retrograde. I think that the correct way to analyze this is this slide right here.
Okay.
Because positive parallax is this. Copernican astronomers will always assume that they are moving from right to left in relation to the stars at all times. Because if this is Joe, or I don't know how he called it, but
Okay.
you will see that you are obviously moving from right to left in relation to the stars.
Okay, I see what you mean.
But that's not what happened, because they are detecting negative parallax and zero parallax. And in the Tychos, due to its geometric configuration, and for example, the Earth moving in its orbit, you will see that 50% of the measured parallax is zero. If you are this guy, you will detect positive parallax, and if you are this guy, you will detect negative parallax. So in the Tychos, the negative parallax detected is not instrumental error, it's just what it is.
And what's this paper that's showing negative parallax and shows that that's what it means by negative parallax? Is that like what paper is this from?
Here you have the reference.
Are you able to pull up that paper so we can take a look and see what they mean? Or maybe I could try to find it, see what this is saying. Because I'm not aware of any understanding of the parallax angle where there's a negative parallax because the star moves in the opposite direction or anything. Uh, uh, uh,
Let me
as a matter of
see.
fact, we don't even how you're describing parallax is not even how we get parallax angles. We just look at the planet on one side of the sun and then look at the planet on the other side of the sun and we see the angle in the middle. So what you're saying is not matching uh, our understanding of how we. So it sounds to me like when they say negative parallax, they mean something other than the meaning you're giving it. If it's some kind of valid scientific thing, but I wanted to pull it up and take a look at it. So uh, why don't we go to and you're saying in these measurements of the annual parallax of the fixed stars, it sometimes happens that the astronomer finds his observation to give a negative parallax. To understand what this means, we remark that a determination of the distance of a star is made by determining its direction as seen from opposite points of Earth's orbit, like I was just saying. And we draw a line from each of these points in the observed direction of the star. The point in which the lines meet marks the position of the star. All right. So in other words, if we're on either side of the sun, and We observe a star in a direction. We draw a line from those points to the star that's the position of the star. Another parallax shows that the two lines, instead of converging at a point, actually diverge, so that there is no position, no possible position of the star to correspond to the observation. Such a paradox result can arise only from errors of observation. Uh, okay, so this is saying that there's an error in observing, not
And
that the planet is going the wrong way or something. But again, why don't we go back to the first article? I mean, we keep scrolling through stuff, and I haven't had a chance to pull up the first thing. Yeah, that right there. Oh, wait, right there. So, astronomical journal results for stellar parallax from meridian transits at the Washburn Observatory. All right, let's see if I can find this article here.
okay.
Results. I didn't find it the first place. Let me look again. Results for stellar parallax from the meridian transits at the Washburn Observatory. Okay, so I found that article. So give me a moment.
This is just to show
I'll
that 20. Okay, this is just to show that roughly 25% of the parallax measure is negative and 25% of the measured parallax is positive.
is interesting.
Here,
Never heard of that
this table
before. So
is
let's take a look and see.
excluding this. Okay.
Give me a moment. Let me download the paper and I will share it and we can look at it over here. And it's
Do
written
you
by
have other
Flint.
article?
Oh yeah, I found it. So let me download it and then I'll be able to share it properly. Right. Let's download it. So it does this. Like it's opening it in the browser rather than opening it up as a regular whatchamacallit. Okay,
I
here we go.
share you a link, a PDF link
No, I
about
found it.
this.
So give me a moment, let me share my screen. If you want, you can stop sharing yours and I'll share mine and we can take a look at it. Right. There we go. Boom. So there it is. Let me make sure the stream can see it properly. All right,
I
there
don't
we
see
go.
your screen.
And you have to click see it in
Oh, yes. Let
Discord. Yes.
me see. Yes.
Let me just make sure y'all can see it properly. Good. So they can see it too. This thing keeps
Yes, I
moving
can
every
see
time
it.
I click it. Okay. Results for stellar parallax from, and this is from an official, place to get, uh, you know what I mean, articles. So let's take a look and see what it's talking about. It says the results herein given are in advance of application of this observatory, which is intended to present the details of observation and reductions, the period of observations. Right. Maybe I should just search a negative in this thing. I know it goes away every time I click the screen, so bear with me. Number of protested by means
Yes.
of products whose the data furnished. Try to see. I'm still not seeing where, in any way, it's suggesting what you're saying it means, that we get in the value from the opposite direction. Uh, but I have never seen anybody present negative values for the negative values of absolute
I see a lot
parallax
of negative
to be
quotes
what
here.
was expected. Well, I mean, I do see the word negative, but I'm trying to see what they mean by it. So, in other words, you saying that this is what they mean by it doesn't mean that this is what they mean by it. Just like how you said the units of gravitational constant don't make sense. That's irrelevant. Uh, uh, so
We are talking. I'm not talking about the gravitational constant here. I'm talking about negative parallax being impossible in the heliocentric model and being absolutely possible and predicted in the typos.
why don't we do this? Why don't I pull up something that's talking about negative parallax? Maybe you can understand what's going on. So why don't we let me share this. And this is the first thing I pulled up, science notes. Uh, I was trying to find a more. Oh, here we go. Here we go. Gaia parallaxes. And let's see what they mean by negative parallax. And Gaia is the most up to date. Okay, so let's look at this. This is up to date. I'm gonna push my screen share about it. So I know y'all wasn't seeing what I had there. Let me stop sharing this and we'll find out what negative parallax actually means. So I appreciate you informing me of this possibility. So go live. Let me know when you can see that. Believe people in the stream could see it.
I can see it.
All right. So stream might have went away. Let me and bear with me because I have to make sure that the stream could see it as well. Y'all should be able to see it now. Awesome. So this is the Gaia data release, astronomy and physics. Seems pretty legit. It's talking about Gaia data, which is a new satellite that came up. Same thing. I did a search for negative so we can see what that's talking about. So it says context. The second Gaia data release provides precise 5-parameter astrometric data positions proper motion parallax for an unprecedented number of sources, more than 1.3 billion, mostly stars. This new wealth of data will enable the undertaking of statistical analysis of many astrophysical problems that were previously unfeasible for lack of reliable astrometry, and in particular because of lack of parallaxes. However, the use of this wealth of astrometric data comes from a specific challenge. How can astrophysical parameters of interest be properly inferred from these data? The main focus of this paper, but not the only focus, is the issue of the estimation of distances for parallaxes, possibly combined with other information. We start with a crucial review of the methods traditionally used to obtain distances for parallaxes and their shortcomings. We will provide guidelines on how to use parallaxes more effectively to estimate distances by using Bayesian methods. In particular, we also show that negative parallaxes, or parallaxes with relatively large uncertainties, still contain valuable information. So according to actual astronomers, negative parallax means it's a parallax with great uncertainty. And this actually correlates with what you said earlier in that one article we were reading, or whatever you showed, it said negative means that there's an observational error. So going back to the first thing I pulled up, I think this is maybe a less official source, but it's talking about the different examples of parallax. So let me share my screen again so we can see what this is talking about. So this is saying parallax. Let me know when you can see that.
Yes, I can see
It
it.
says parallax definition uses examples. Parallax is the apparent shift in the position of an object when it's observed from different points of view. This is what you showed, except with a car. So we know that that's what parallax is. Is the apparent shift in position. Types of parallaxes. The three types of parallax positions are positive, zero, and negative parallax. The distinction depends on the relative motion of an object against its background as the observer's viewpoint changes. Understanding these categories helps in various fields, including astronomy, virtual reality, and 3D imaging. Uh, Positive parallax. Parallax occurs when an object appears to move to the right relative to the background as an observer's viewpoint shifts to the right. When the observer moves to the left, the object appears to move to the left. This suggests the object is closer to the observer than the background. In stereo imaging, positive parallax objects appear as if they're in front of the screen, enhancing deposition. Zero parallax happens when there's no apparent motion of the object relative to the background. The observer changes position. This occurs when the object is at the focal plane of a camera at a point when the sight lines from the different viewpoints converge in practical terms. Negative parallax occurs when the object appears to move in the opposite direction of the observer's movements. For instance, if the object moves to the right, the object shifts to the left and vice versa. This type of parallax indicates that the object is farther away from the observer than the background. Okay, so this is saying that negative parallax is when the object that we're looking at is farther away from the observer than the background. In stereo imaging, negative parallax makes objects appear as if they are behind the screen. This adds depth to the background and enhances the viewer's sense of immersion. So this seems to be from physics optics. So this is more, okay, so this is more about cameras is what this is talking about. That's why it's saying, in other words, it's saying that we're taking a picture of an object with a camera and the object is farther away than the background. So it's kind of like if there's a tree in the middle and there's the object is behind. So this is not really related to what we're talking about specifically. This is talking about optics in general.
Yes.
But yeah, so nothing.
I would love. Listen. I would really love you to take a look deeper into this thing about negative parallax. But let me show you one more thing that is curious about the Tychos, if you let
Let
me.
me go now. Are you conceding now that negative parallax either means in photography, because I was talking about optics, that the object is behind the background, or when we looked at the astronomy article about the Gaia data, it's saying that the data is imprecise. Just like how something you showed earlier, it said that parallax is
So
error in observation.
why the data is imprecise about negative parallax, but is perfect for positive parallax, and we use it to detect it to predict the distance to stars? I mean, seems like
Say that
random that they
say
choose
that again.
what seems to be random. They choose positive parallax to be great and awesome and perfect to determine the
What
distance to stars, but when the negative parallax show, they say it's instrumental error.
it is? It's in
and
your
and
own evidence. You
it's,
presented. What
it's in public document that negative parallax is detected. I mean, I lost you. I can hear you. I don't
my
know if
mic
you
by
hear
mistake.
me.
Why don't you share your screen again and open up your the page you had about negative parallax so I can show you that it even correlates with what you're saying. Like you had a page, so you had a whole bunch of documents you were scrolling through that was mentioning negative parallax, right? Not so like you had the thing that remember when I pulled that document up, they had the title of that document. It must be in the slide you were sharing. Where's all the stuff in the slide? Remember, go back to where I pulled the title of that paper, and the title of that paper was there. Remember when I got the title of that paper? What were you showing right there?
Yes.
And then and there was another thing that had that as well. It was like a whole bunch of negative parallax stuff.
This let me was this one.
And scroll.
Are you seeing my screen of?
Yeah, I can see it. Hold up. This is not what I was looking at. So matter of fact, look at the bottom paragraph there. Are you able to increase the size of that, by the way? Like it's really small. Like, are you able to zoom in on it? There you go. Like keep zooming in on it. Yeah, yeah. And scroll down to the last paragraph. Does it scroll? Like maybe it's so I guess you have to go scroll, make it smaller again. but it was in the bottom. This is not the exact one, but matter of fact, it would be on the stream, I think. Maybe I could just find it on the stream. But it's in this one too. Like scroll, like go a bit smaller so we can see the bottom paragraph. Like keep zooming out until we can see the bottom paragraph of that thing. So even worse, as in the previous case, a little bit bigger. Even okay, right there. Even worse, as in the previous case, with the truncation, and maybe I should truncation that only makes distribution true of distances, but is also the distribution of observed parallax. Stars with positive errors, making the observed parallax larger than the true one, tend to be less removed than stars with negative errors, making the observed parallax smaller than the true one, which in respect to negative errors. So, and also, I can actually find it in the stream. It goes back. So in other words, it's like this. But this is common with flat earthers. You're using parallax. You're talking about parallax, but you want to only take a part of the definition of parallax. The people who made the definition for parallax are also saying that if there's an error in observation, it comes out negative. But now you're saying no. I'm going to disregard what they say about parallax, and I'm going to give it my meaning. Parallax means the planet is moving in the opposite direction, and that's impossible. You giving your own meaning to things is not valid. Just like how when you were saying that the units don't make sense, you giving your idea that it doesn't make sense doesn't mean anything. But give me a moment. I'll try to find that part of the stream real fast. So bear with me. I'm pulling up the stream here real fast. So, and I'll just scroll through it and find that part when you were sharing the quote I'm talking about. It was very brief because I was trying to stick with the first quote. But I did happen to notice that quote. And then the article I found corroborated with it being an error in observation, right? So, here. Before this, so hold up. For the black document, pull up the document. Is on your tabs. It says the Tychos.
Here.
That's right. And scroll up to like search observational. Like control F, like observation. And it'll come up. Let's scroll through the observation ones. Like you see that there's a little downward arrow by your where you type observation at the bottom. There's a downward arrow where you can scroll through observation.
Yes.
Like move your mouse all the way down to the left where you typed in observation to search. Oh yeah, they're right there. That's it. That's it. Go back one. Go back. There you go. Such a paradoxical result can arise only from errors of observation, right? And that goes back to what I read.
Yes, I know. But it's funny that the heliocentric model is explaining it with errors of observation, and the Tychos shows exactly what is empirically observed.
You haven't shown that.
That's the interesting thing.
I hear you saying it shows empirically, but you're not demonstrating that. I asked you to predict an eclipse and you were wrong. So you saying it shows it accurately doesn't mean it shows it accurately. If you want to show that it shows it accurately,
it shows it accurately because it's the geometric configuration. Here you can see.
If you want to show that it shows it accurately, what you need to do is you need to actually predict things and get it right. Not we give you the coordinates and then you plug it in. You need to give us the coordinates. You need to say this model is accurate, and I can tell you what the declination is going to be of the moon and so on and so forth.
If you give me the time, I can search for the next solar eclipse.
I've already did
in
that.
The Tychos, give me the time. Because I just run the software and make a wild guess of when it will happen. I'm not claiming that the system is exactly saying that in that date the solar eclipse will happen. So
I hear you, man. So what about kindness, man? I see you dropped in. Do you want to say something before we close up?
Yes, I want to talk about the Halley's Comet.
I was actually real kindness there because we have someone had joined the Discord. We'll see if he wanted to say something. Maybe he's just listening, or maybe he went AFK for a little bit. All right, so I guess he doesn't have anything. So last thing, what do you want to say about the what do you want to say about about the comet, the Halley's comet?
Well, the Halley's Comet is supposed to do this cigar-shaped orbit,
Okay.
and it's always moving in a retrograde fashion. But in the book, it has a really good ephemerides of Halley's, and it shows that a guy named Palist and Messier saw Halley's moving prograde, which is impossible. And what they did is delay the announcement after they actually saw Halley moving in a retrograde manner. Another thing that I would like
Well, I
you
mean, let's
to
stay on
take
one
a
thing first. I mean, are you
no,
saying
no,
that?
it's this because
Okay,
this is another curious thing because just by coincidence, by the time roughly same years that Halley is doing his approach to Earth, other astronomers find new comets, and
here's the
they
thing,
name
man.
it the Tumlock's comet.
Let me just share my iPad, and we could scroll this right here, and then we'll close up. So give me a moment. Let me share my pad real fast. I got to join on my let me join Discord on my iPad. Right. So I haven't really looked into Halley's Comet a lot, but let's look at the orbit that you pointed out there. Okay. So share screen, share, right. And after it shares, I'll click on that. And hold up,
Yeah.
there we go. And if you would stop sharing it, you can look at my screen there. Right. So
Okay,
and let me know when you can see it.
I see it.
All right. So we have the sun there, looking down from the top. We have the Earth here, right? Would you say that the Earth is going faster than Halley's Comet or slower than faster than Halley's Comet?
Slower. Halley's has exactly the same orbital speed as the Sun in the Tychos.
No, no, I'm not talking about. I'm talking about the globe. And you say it is impossible in the globe system, in the heliocentric system. So I'm asking, in the heliocentric system,
The-
in our understanding, is Earth going around the sun, or is Halley's Comet going around the sun? Which one is faster?
In the heliocentric model, Halley's is faster because it has a big elliptic
So,
orbit.
so, so that seems to be what the misunderstanding is. Um, Put it like this: if I'll see what you mean. Let me get the actual data because I'm trying to guess. Let me get the actual data of the Halley's Comet, and I can make sure it's accurate. Uh, so I can point this out. Halley's Comet orbit. Halley's Comet orbit. It takes 72 to 80 years, it appears. So we'll just say 77 years. We know from Kepler's laws that the period uh, is that's going to be the relation between the period of Halley's comet and the semi-major axis. I'm going to need more room, so I'm going to move this down a little bit. Right. So that's going to be the period. So we have Halley's comet like this. Right. Right. So Halley's comet takes 77 years to go around. How fast? Let me see if I can find out how fast it's going. Maybe instead of doing this calculation, they could just tell me. Uh, fast is Haley. But this is what I'm looking at, by the way. I see what you mean as far when it gets close, it's going faster. This is what I'm looking at. If Haley's comet is here, I'll make Haley's comet a different color. If the Earth is coming past it like this, then it could look like Halley's Comet is going the other way. If we see Halley coming in here, and Earth is moving in this orbit here, I can see it looking like at
Yes.
that moment Halley's is going the wrong way. Just like how if we're looking at Mars, if Mars is here, right, when Earth is doing like this to make all of this bigger, right? Earth is doing like this, it looks like Mars is in retrograde. Do you understand what I'm saying?
Yes.
So if Earth can make Mars go in retrograde, why can't Earth make Halley's Comet go in retrograde? That was a real question. So
Uh,
so so
yes.
Earth.
Halley's will always supposedly to move always retrograde,
Oh, so you're saying the
but it's
problem is
not.
that sometimes it's not retrograde.
Yes.
Okay. So Earth is there. Mars is Halley's Comet is now on this position. If Earth is here, is Halley's Comet in retrograde?
Yes.
No, it's not. Because Earth
In
is
the
moving this
in the
way. Earth. I'm
heliocentric
talking about
model,
what I
yes.
have on the screen right now, right? Earth is going like this, and maybe I need to make this a bit bigger. Earth is doing like this.
Yes.
And, okay, I'm just going to just name the
Halley's
Mars
is
one.
moving retrograde.
Earth is doing like this. Halley's is doing like this.
No, Halley's moving the other way around in the heliocentric model. It's going in the
Oh, I see.
opposite direction.
Well, I'm not familiar with Halley's Comet, so I could just, yeah, but I won't be able to figure it out in time. So we could just leave that the way it is then. But yeah. So in other words, you're saying that it one time it was going the opposite way and it shouldn't have been. Okay. Well, I guess people could look at that if they want.
Yes.
I'm not familiar enough with Halley's Comet to answer to that. But awesome.
I would really love for you. I think you're studying astronomy, right?
Yes.
I would really love for you to take a deeper look. I mean, an honest and deeper look into the Tychos. I mean, you have there's a free book. There's the 3D model viewer. Uh, I really hope you can take a look into it and do a review. I mean,
And do a
if
what?
you prove that it's impossible that the model doesn't work, I'd be happy to listen. I mean, I'm just learning here.
I've already proved that it's not working so far. I mean, I've already given you the opportunity. This is the way it works, right? Science doesn't work that we have to look at everything people present and prove it wrong. That's not how it works. We have something that's working. So the way it works is if you're saying that
No, it's
works,
not working. It's not working because negative parallax is impossible in the heliocentric model.
you already
That's a fact.
addressed that. What did your own document say negative parallax is?
No, you
I'm asking you,
negative parallax is
what did your own
in
document
is.
say negative parallax is?
I show you with the car and the light post and the study background,
What did your own
and I show
document
you
say?
what it is.
What did your own document say negative parallax is?
I just show you in the slide what negative parallax is and why it is impossible.
I hear what you're saying it is, but I'm asking you, when we read it, what did your own document say negative parallax is? I'm really asking.
I don't care what
Okay, then, man. Well, we might as
negative
well end, man.
parallax
We might as
is.
well end right now. This is what you can do. You go ahead and show that it works. You go ahead and make some predictions and get it accurate and show that it's more accurate than the global model. You're not going to get even me or any whether a scientist in training or an actual scientist to take their time to look up something that you just because you say it works to prove it wrong. That's not how it works. What you need to do is actually demonstrate that it works better than what we have, and then we look at it. We
Yes,
don't look
it
at
works
stuff just because
better
people.
because it fits better the observation.
You haven't showed that so far, right?
It
You haven't
fits.
showed that so far. So,
Yes, I
but
show that. I show the paper with 25% of the parallax measure is negative, 25% of
but
the
you
measured
but you
parallax
but
is
you're not
positive,
honest
and
enough.
50.
But you're not honest enough to say what your own document said the negative is. That's the difference. You're showing this car thing, and you're trying to
Yes, I
tell
show
me
you
this is
what
what negative
negative.
means,
I show you what
and I
negative
don't
parallax
believe you.
is with
I
the
don't believe
cap
you. Just
and the
just
light
like
bulb.
just like just like I don't believe you
Well,
when you
that's
say just like I don't believe you when you
you
say the
don't believe me,
constants.
but
Just like
that's the
just like
fact. I mean,
just like I don't believe you when you say the constants of the G value don't make sense. I don't believe you when you tell me that's what negative parallax means when I read an astronomical document talking about the Gaia data that talks about it being an error in observation, and your own document said it's an error in observation. So what you say doesn't trump what
yes,
actual
the
astronomers say,
document explained it.
right?
Yes, the
So
document
what
explained
you
it
say,
with observational error,
yeah, exactly. So now you
but
finally
there
was
is a
honest enough to
model
say what it
that
says.
exactly
So
predicts.
all right, man. Yeah. It's good. It was good talking to you, man. I guess everybody can make their determination, but I won't be wasting my time looking through that book trying to prove it wrong. I have rulers trying to me to study, but again, if you ever actually get something that's actually working and can show that it's working, I'm happy to talk to you again. If you could show that it's working and it's better than the globe what we have, but so far I'm not seeing that. So, we're good seeing you
The
on board,
Tycho's model
Carlos.
is a glove
Uh,
model.
I'm sorry.
It is a glove
I'm sorry. I'm
model,
used
you
to
know.
saying globe. I'm not bad. I'm so used to globe flat. I guess let's just say the heliocentric model, and the tychocentric model.
Yes,
When you can show that it's working better, then yeah. But I'm not going to take my time to
yes.
study it to prove it to be wrong, especially when I've already seen that it's just a bunch of. I'm just saying that this is the way it is with nothing to really back it up, even though it contradicts your own
No, I
evidence.
mean it's data.
You gave the
It's
evidence of the
observational data
Wikipedia.
that
Yeah,
negative parallax is a fact. I mean,
I hear you, man. I hear you. But it was good talking to you, man. And so I hope everybody enjoyed. And I'm about to go get something to eat. And and we'll see everybody next time.
see you next time. Thank you.
Uh-huh.